All right. So we have been doing this for one class. So how do you feel? Are you okay with this? Or am I speaking too fast? Too fast or too slow? Or just okay? Okay? So that's good. So we're going to teach this. I'm going to speak like this. Within the first 4 or 5 classes, I'm going to speak faster and faster in the future. Because I have to. There is a lot of material we have to cover. And the lecture notes, the lecture hours is actually very limited. 48 hours is not too much. Okay, so, but we have a adjusting period. For the first 4 or 5 times, we will be following this speed. Any questions so far? Any questions? Not just about this course. I just want you to speak. Any questions? The first student who reads out questions will get 2 extra points in your final score. Okay, please.
You mentioned as well if you will take a quiz.
Right? What?
Will you mention us before you take a test?
Okay. Let me rephrase the question. Will I remind you or let you know long time before I'm going to take a in-class test? I'm not going to do that. I'm going to just, when I feel I need to do a test, I just do a test. That's a good question. You got 2 extra points. What's your name? No? Cai Boyan. Okay, good. Any other questions? Yes, please. But you are the second. You do not have the 2 extra points.
Okay, my first question has been answered. The second question is that you have mentioned that you think in China, translating some technology words into Chinese is very good. But last time I exchanged to Taiwan.
Okay. Yes, they are using. They do not have this translation. They're usually
some of the words.
Most they do. Most of the words they did not transfer.
Yeah. Because I have talked about this topic with some Taiwan professors. They say that translating these words are not very good for our communicating because different professor has their different ideas about this translation.
Well, that's why we are trying to unify the translation. We have a standard. Actually, there is a standard. There is a standard in the China mainland about the Chinese translation of almost every English terminology in each area. We have a standard. But it's just we don't have agreement with the colleagues in Taiwan yet. That's the problem. So if you are communicating in the China mainland, there's no problem. Everyone is talking about the same thing when we are using a Chinese translation. But when you communicate with professors or students in Taiwan and even Hong Kong, sometimes they do have problem understanding the Chinese version of terminologies. Oh, that's true. Okay, but I believe this process this process of always having a Chinese translation of all the terminology, that's good for the language. You keep your diversity. The Chinese language, they keep their diversity, and it's also very good for communicating among Chinese people, Chinese engineers, Chinese professors, Chinese scientists. So that's just my personal view. Good. That's good. Okay. I'm very glad that you are not just thinking the things in the class, but also related to the class, but also some other questions. That's very good. All right. If you have more questions, we can discuss later. And when we figure out the office hour, you are very welcome to come to my office, and we can have face-to-face discussion. Okay. There are students asking. So in the future, every course, almost every course, will be video recorded, and put it on all this video material will be put on the web, so everyone have the access to the lecturing material, and even video. And why do we come to the university? We can just sit at home and watch those videos of lectures. So how do we answer that question? Why do we come to the university to attend classes face to face? You have any idea? Your opinion? So my opinion is, in the universities we have interactions. That's very easy for us to interact. I ask questions, you answer my question. You ask questions, I answer your questions. That's interactions. You cannot have this interaction through the internet right now, at least. And what is more important, you have communications with professors, with our TAs after the class. Okay? Professors, students, these are the most important resources that you cannot have off the campus. Only on the campus you have access to professors, you have access to students. And professors and students are the most important thing for your learning. Okay? That's my understanding. So even if in the future you can have interactions through the internet with professors, still on-campus teaching and learning will be very important. Still, this will be very important. This cannot be replaced by internet. We have to have face-to-face discussion, a lot of things. Okay? So please come to my office and talk to me. That will be very benefiting to your career, to your learning. Okay? Come to my office, come to our TA's office, talk to them. All right. We had too much discussion. Power electronic system is the usual form that a power converter appears. And also in this picture, I want to let you know that when you look at the power electronic system, you have an input side, you have output. We are convert and control this input power to output power. There are several examples of where this input power comes from. Okay? There are also several examples of where this converted power or controlled power is going to. Okay? The examples are, for the input, it could be electric utility. This input power could be coming from electric utility. Utility is a very useful word. Utility, I don't know whether we have a very short Chinese translation of that. And I'm not sure whether this is a very good translation. Utility is very good. I mean, a very good name for the network. Utility actually means the network that is supplying public access to some natural resources, or some resources, not just natural. The public network that is providing access to resources like water, okay, gas, okay, electricity. Those network is called utility. When you are providing those resources to public, those are called utility. Electric utility, that means the utility that is providing electricity to public. Okay, so that electric utility, very often we translate that the whole phrase into very often we translate into that. Okay, electric utility. Probably not a very good translation, but very often we translate that into. Okay, so the input power could be coming from electric utility. It could be coming from a battery. You know this, battery you know. Okay. It could be coming from other electric energy source. Utility, battery, these are the two things that we have energy sources very often. But there could be other energy sources. And finally, it could be also coming from another power converter. In the future, you will know the input power of one power converter might be coming from another power converter output. Okay. If you look at the output side, the load of this output power could be a lot of things, because you have all different users of electric power. In the modern society, everyone, everywhere, we have to use electric power. Okay? So this output side, it could be many things. It could be electric motor. Okay, that is one thing. Electric motor, I believe you are now in this semester also learning a course about electric motor. Okay, it could be light. Okay, it could be heating. Okay, heating facilities. It could be also another power converter. Okay, so this power converter is generating power and providing another next power converter. It could be like this. In the future, you will see this. Very often you see, actually, you have several power converters working together. One power converter is responsible for one thing and transfer that power to the next one. The second power converter is responsible for controlling or converting another thing and then transfer to next one. So this is very often in the future. Okay, it could be other electric or electronic equipment. Okay, when we understand this, then power electronics, if you want to have a better understanding, actually, the objective of power electronics has been extended. Remember, we have discussed before that power electronics is trying to convert and control electric energy so that you can provide to the user or to the load a best suited voltages or currents. So when we talk about this definition, we always talk about how to better suited for the loads. Those are the original definition. But now, in recent years, the task of or the function of power electronics has been extended also not just to meet the need of load. In many cases, this is also used to meet the need of source. Okay? You may not have a very good understanding of this, but you will see this in the future. This can be extended to also ensure the currents and the power consumed by power converters and loads to meet the requirement of energy source. This is also included recently as the task of power electronics. Okay? Another way of understanding power electronics is to discuss the relationship with adjacent areas, with other disciplines. Let's see. Power electronics, as we said, is part of a kind of electronics. Okay? So let's see, in electronics, other than power electronics, what do we have? I'm listing here information electronics. Other than power electronics, actually the counterpart to power electronics is information electronics. Okay? Okay, let's see. Why is this? Because if this electronics is applied to process energy and electric power, then it's called power electronics. If this electronics is used to process information, then that is called information electronics. Okay, so that's very easy to understand. So in general, electronics can be classified according to the application area. For example, when we talk about computers, okay, when we talk about this video projector, a laptop, and MP3, your cell phone, these are all processing information. Either generate information, transmit information, receive information, or convert information, or display information. Those are all about process of information. So that's called information electronics. Power electronics is the other side. We all talk about how to process power, how to process energy. Okay? That's one classification. Another classification might also be very useful for you to help you understand the definition. According to what kind of devices? According to what kind of devices you are basically using, electronics can be classified into vacuum electronics and solid electronics. Vacuum, you already know this. Vacuum electronics. And solid or solid state electronics. That's based on what kind of devices. If you are using vacuum devices, let's see here, vacuum devices, then this is called vacuum electronics. If you are using solid state devices, then you are called solid state electronics. Vacuum devices, vacuum tube devices, you probably cannot see this very often right now because this is seldom used. Okay? For example, most of you, I believe, you never see this before. Okay? Vacuum devices. Maybe your father, your mother, their generation, they have chance to see this vacuum devices equipment. For example, radio receiver. Radio receiver uh, 20 or 30 years, 30 or 40 years ago, I would say, when people were still using vacuum tube devices, radio receiver, it's very big. Okay, usually a radio receiver is as big as at least this laptop, I mean this size. You have a radio receiver, very, very large, very big, because each vacuum tube device is very large. Okay, later on, when semiconductor devices appeared, okay, semiconductor devices appeared. Semiconductor devices, they are much smaller than vacuum tube devices. Therefore, you can make a lot of things much smaller. Okay? So, according to the devices you are using, we can classify this into vacuum electronics and solid state electronics. Why is it called solid state? You guess? Why is it called solid state? Solid. Solid means there is nothing moving. Right? Solid means this is a static, nothing is moving. At least by visual, by your eyes, you cannot see anything moving. Okay? Vacuum tube, you still see vacuum tube. Probably some of you know is the mechanism of vacuum tube is to generate a beam of electrons. Usually, you have to generate a beam of electrons. So, looks like there is something moving. You generate a series of electrons, and this electrons is moving from this side to that side in the vacuum tubes. That's the intuitive understanding. But actually, in the semiconductor devices, there is also electrons moving. You know that, but you just cannot see that. All right, another classification. This is a classification based on devices, what kind of devices you are using. Okay. There's another classification based on different levels of issues. If you're talking about physics, physics mechanism, if you're talking about the material to make electronic devices, if you're talking about the fabrication, how to build electronic devices and electronic circuit, and how to manufacture the electronic devices, when you talk about these things, then this is called usually physical electronics. And if you're talking about applications, we're not talking about how to build these things. We're talking about how to use the devices to make electronic circuit, how to make electronic equipment, then that is called applied electronics. So in this way, according to different levels of issues, we can classify electronics into physical electronics, and applied electronics. Okay, so we can classify electronics according to different aspects. So when we talk about power electronics, so power electronics is a classification based on applications. So the counterpart is information electronics. But if you're talking about what kind of devices we're using, power electronics could be using vacuum devices, could be using semiconductor devices. Okay? And you can imagine using semiconductor devices will be much better than using vacuum devices. Okay? When we talk about power electronics, we could be talking about physics. We are going to talk about the physics of operation of all different kinds of devices we are going to use for power converter. We also are going to talk about how to use those devices to make power converter and to how to make power electronic system. Okay, there is another suggested picture by Dr. William Newell in the 1970s. He proposed that power electronics can be illustrated using this picture. It is a triangle. Then along the three sides of this triangle, you have electronics, you have power, you have control. Okay? Those are the three things that very tightly related with power electronics. Or in another word, power electronics is the interface between electronics and power. We use electronics to control power or convert power. That is another explanation for your reference. There's another picture which I borrowed from your English reference book, which shows all the different areas we might be having a very tight relationship with power electronics. You have systems and control theory. Let me put the Chinese name here. System and control theory. Okay, you need to know signal processing. Okay, you need to know simulation and computing. Okay, you need to deal with electronics. That's for sure. This is a part of electronics. But this here, I believe they mean information electronics. Solid state physics. Okay, and you have to know electromagnetics. Okay, power systems. Okay. And electric machines. Electric machines. Okay, circuit theory. You already learned this course, I believe. Circuit theory. Okay, these are the different areas we have to that have very tight relationship with power electronics. Okay. So because you can see that power electronics has such kind of tight relationship with all these different areas, power electronics is really considered the most active discipline in electric power engineering. When you talk about electric power, this thing, power electronics, has a very tight relationship with not just electric power, but also all the other very wide area. So this is the most active area when you talk about electric energy. The position and significance in the human society, I just put 4 statements there. I believe you can understand this. When we let's read through this together. Electric power is used in almost every aspect and everywhere of modern human society. That's true. I believe you agree with this. Okay? Electric power is the major form of energy source used in modern human society. That's also true. Okay? The major form of energy source. Third, the objective of power electronics is exactly about how to use electric power and how to use it effectively, efficiently, and how to improve the quality and the utilization of electric power. So power electronics is exactly about this, exactly talking about how to use electric energy, how to use it efficiently and effectively. So this discipline, power electronics, is really about utilization, better utilization of electric power. So therefore, based on the first 3 sentences, I have the last statement. Power electronics and information electronics make 2 poles of modern technology. Pole. Do you know pole? Power electronics and information electronics make 2 poles of modern technology and human society. It's just like a human body. If we consider the human society as a body, human body, then you can imagine information electronics is just like the brain, like your brain. Okay? Power electronics is just like the muscle. Information electronics provides all the information, decision, control, commanding, reference, all those things. Power electronics is providing energy. If you want to do something, if the human society want to produce anything, you need power. And that power is directly related with power electronics. So that's why I'm saying this. They are the 2 poles of modern human society. A very brief history. I'm not going to spend too much time here of power electronics, history of power electronics, because right now you don't have any understanding of those terminology yet. Those are the different devices, different semiconductor devices we are going to use in the power electronics area. So, very briefly, the history can be classified into 1, 2, 3, 4 phases. Let's see. You have prehistory before 1957, because in 1957 there's a very important event, the invention of thyristors. in 1957, we have the invention of thyristors. Thyristor is a special name. Thyristor. In 1957. It's just like the invention of transistor. I believe you have learned this before. Transistor. Or sometimes just this. Transistor, the invention of transistor in 1940s, that is a big event for electronics. Because devices are changing from vacuum devices to semiconductor devices. Okay? So it's just like that. In 1957, there is an invention of thyristor. That means before the invention of thyristor, people were still using vacuum devices. A lot of vacuum devices. Okay? After that, people gradually changed to use semiconductor devices. So the invention of thyristor is really a very important thing. So before that, people were using mercury arc rectifier, vacuum tube rectifier, thyrotron. A lot of those are the names of vacuum devices in power electronics. Let me put the Chinese translation to that. Okay, you have mercury arc, rectifier, okay, vacuum tube, okay, thyrotron. Well, you have many different names there, but I don't know what they are actually. But they are vacuum tube devices. And since 1957, because of the invention of semiconductor devices, thyristor, we gradually move to semiconductor device. Because semiconductor devices, they have much better performance than vacuum tube devices. And then the second stage was appearing in the application of fast switching, fully controlled semiconductor devices. Fast switching, fully controlled. I will not give you the Chinese translation this class. I will give it later for the next classes. When these new devices appears, they have much better performance than thyristor. Okay, that opens a new era of the power electronics history. Okay, so before that we have just power diode, thyristor, and after that we have so many better devices. Okay, and then in late 1980s and early 1990s, you have a newer generation of better devices. Okay, these devices are better than the previous ones. Okay, so you can see the thread of power electronics history precisely follows and matches the breakthrough and evolution of power electronic devices. This history is exactly following the evolution of devices. When you have better devices, you open a new era of history. Okay, this is the thing I want you to remember. You probably don't understand those names. You will understand in the future. But one thing I want you to follow is that this history is always following the devices. Applications of power electronics very wide, as we already mentioned, because this is dealing with how to use electric energy. Every time when you want to use electric energy, you probably need power electronics. So you can understand everywhere, almost everywhere, we need power electronics. We have an illustration in the following pages from page 14 to 21. 14 to 21, there we have several pages of listing of different applications of power electronics. I'm not going to go through this in the class. I ask you to look through this list and find out the Chinese translation yourself. Okay? For all these different application areas. You find out the Chinese translation yourself after the class. And probably I will check next class. Okay? I'm not going through this. Okay? We do have a few words here regarding the trends, the developing trends. When you talk about one thing, people always try to talk about what is the developing trends. Let's see. It is estimated that in the developed countries, now 60% of the electric energy goes through some kind of power converters before it is finally used. So most of the energy has to go through a power converter before it is finally used. 60%. Well, it's just a very rough number. Okay? Power electronics has been making major contributions to better performance of power supplies and better control of electric equipment. If you want to have a better performance of the electric equipment, then you have to go to power electronics. Okay? If you want to do energy saving, of course, power electronics, because this is exactly talking about how to use energy efficiently. Okay? If you talk about environment protection, this is also contributing a lot. Okay? Because we can, power electronics can bring us the reduction of energy consumption. Okay? Less energy consumption leads to less pollution. Okay? It can also bring us reduction of pollution produced by power converter. If you have better power converter, if you have better understanding of power electronics technology, then you can build better converter, and therefore you reduce the pollution generated by power converter. And in many cases, power electronics is also directly applied to the environmental protection engineering. Well, that's, in those sense, power electronics is really very important. Before we close, actually, I want you to have a feeling of what power electronics is. Let's take this example. We still have several minutes. This example. Let's see. The objective is to convert this 100 volts DC energy into 50 volts DC energy for the user. The user requires 50 volts. That's the unit of voltage. Changing 100 volts to 50 volts. Constant. The user wants a 50 volts constant DC energy. How can we realize that? Okay, let's see. Give you another condition. The load is a resistor. Looks like a resistor. And it is 5 ohm. Let's see, not 5. Oh, yes, 5 ohm. 5 ohm resistor. And we want to change the input side 100 volts DC energy to 50 volts constant DC energy for the load. How can we realize this? You have any suggestion? Any suggestion? No suggestion? You cannot handle this? Or you simply do not want to stand out? What is your suggestion? Well, at least I have one suggestion first. I can use another resistor, right? Because the load is 5 ohm, and I can use another 5 ohm resistor put in between this input and the output. I use another 5 ohm resistor, and therefore the load, we have 5 ohm here, 5 ohm here, therefore the load will have half of the input voltage. That's 50 volts. Okay, that's one solution, very simple solution. Then what is not good about this solution? Let me know. What is not good about this solution? It's a waste of energy. Because half of the energy has to be wasted on this resistor. The load can only receive half of the input energy. So the efficiency is 50%. That's too low. Half of the energy has been wasted on another resistor. That's not what we want. Okay, that's the first bad thing. What else? Very, very good. What else? Let me put it this way. I said load can be changed. That's good. That's engineering. Engineering, you will see very often load is not constant load. There's always disturbance in the load. That's the actual practical word. Load is not ideal, constant resistor. Load could be changing. Even if it's always a resistor, the resistance could be changing from time to time. For the current state, it is 5 ohm. It might be changing to 4.9 ohm later on. Okay, it might be changing to 5.1 ohm. So in the real world, in the practical applications, there is always disturbance coming from the load. Disturbance. Coming from the load, okay? That is one thing. You will always see this. Load could be changing. There's always disturbance in the load. Actually, in addition to that, there could also be disturbance coming from the input. That's also very often. You often see this. Those are the two sources of disturbances for the practical applications. Not just for power electronics, not just for electrical engineering. It could be for every engineering area. Those are the two sources of disturbance. One source is coming from the load, the other source is from the input. You always have disturbances. So how do we handle these disturbances? If you put a resistor, okay, that's fixed, 5 ohm resistor, when this is changed, then you don't have 50 volts. That's not satisfying our requirement. Okay. Maybe we can stop here. You propose another solution. Let's see, next class, what kind of solution you can propose to deal with this problem. How can we realize an output of 50 volts constant for a 5 ohm load, but with very high efficiency, one aspect, and another aspect with constant voltage, even when there is disturbance. Okay? All right, homework. read through the textbook, chapter 1. Okay. There's a lot to read. And also the English reference book, page 3 to 9. Oh, actually, 3 to 14. 3 to 14. Also, first chapter, chapter 1. Okay, those are the reading assignment. And remember, I want you to translate all the application areas, okay, in the lecture notes, application areas into Chinese. Okay, and you think about how to solve the problem I proposed in the class. All right, that's all for today. I'll see you on Thursday.